Right, welcome back. Today I'm going to talk about completing the square. Now, many students don't even understand what completing the square means. They only memorize how to do it, and it's not a good way to learn this topic. All right, so I'm going to explain what completing the square really means. What is completing the square? All right, let's talk about perfect squares first. What's a perfect square? What is a perfect square? Okay, I can tell you that perfect squares are 1, 4, 9, 16, 25, and etc. Right? Because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25, right? Or I can write it as 1 square equals to 1, 2 square equals to 4, 3 square equals to 9, 4 square equals to 16, and so on. Right? Now, so we know what is perfect square. Now, how about this? I give you a quadratic expression and I say it's a perfect square. This plus 4. Okay? Now, how do I know it's a perfect square? Let's do a quadratic factorization. Okay, you can either do your uh, cross method or you can do your using your calculator and you should get this. All right? And this is this if I combine it together. All right, so I'm just going to show you one time. If I really do it out, x squared, 4, so x. What can I get? 2, 2. Is it correct? Yes. So 2x, I get 4x. Okay, so why is this a perfect square? Why is this a perfect square? Because it gets me this. Okay, just like all this. Okay, 4 is essentially 2 square. So I can give you an example again. Maybe x squared plus 6x plus 9. And I tell you, this is a perfect square. So why? Let's try it out again. X squared, 9. X, X, and perhaps 3 and 3. So I get 3x plus 3x is 6x. So I'm correct. So it is x plus 3, x plus 3. And therefore I get x plus 3 squared. Now, how did I know how to create quadratic expressions that end up being perfect squares? Simply because in a quadratic expression, ax squared plus bx plus c, where a, b, and c are numbers, of course, if b over 2 and I square it, if this answer is equals to c, then I know that I have a perfect square. Okay, so for example, what do you mean by b over 2? Look at this, x squared plus 4x plus 4. Okay, so b over 2 means 4 over 2. Then if I square it, it's actually 2 square, which is actually 4. And this is the same as c. How about the next one? X squared plus 6x plus 9. Okay, what's my b? My b is 6, right? So if I take b over 2, so 6 over 2, and I square it, I should get 3 square, which is 9. And it is equals to c. So now I know that this is a perfect square. So what has this got to do with this whole topic? Let me clear my screen. Uh, so what's the purpose of completing the square? Is to help you solve quadratic equations. It is one of the ways. Now, also, once you have completed the square, you can find turning points of a quadratic curve, like the coordinates of the minimum or the maximum point. So, based on what I taught you just now, let's look at what completing the square really means, okay? Now, if I look at this, minus 10 is b, right? Over 2 square. It is minus 5 square, which is 25. This is not this, right? So is this x squared minus 10x minus 2, is this quadratic expression a perfect square? It is not. All right, so what I'm going to do is I'm going to force it to become a perfect square. How so? Take a look. X squared minus 10x. Now, I want to force it to become a perfect square, right? So I said b over 2 square. Right? Now this will be a perfect square. Right? Then my students will say, but this is not equal, right? X squared minus 10x minus 2 is not equal to that. Yes, of course. So if I plus this, I must minus the same thing. And then minus 2. Now are they equal? Now look, I added this and I subtracted this. Isn't this still the same? Because this 2 is 0, right? So this is still equal to the last expression. Then my students will ask, then what are you doing this for? You get 0 again, then you get back x squared minus 10x minus 2. No. What's going to happen now? Let's simplify first. X squared minus 10x. If you use a calculator for this, you should get 25. And then I get minus 25 and then minus 2. Now, of course, I'm not just going to take 25 minus 25 to get 0, okay? What's going to happen is this is a perfect square quadratic expression. So I'm going to key this into my calculator. And I get x minus 5, x minus 5. Okay, there will be only one answer. That means it's a perfect square. So I can write this. And minus 25 minus 2 is just simply minus 27. Okay, and I can actually write this as x minus 5 square minus 27. Okay, so see what has happened. Look at this. I have forced this into a perfect square, which is actually this now. Okay, then whatever else is remaining will be outside the perfect square. So most of the time, students will just skip this step, which is fine. All right, so the meaning of completing the square is I'm forcing this quadratic expression into a perfect square, even though it is actually not. Okay, so let's try example 2. X squared plus 6x minus 2. Let's think again. Let's do it at the side, all right? Is this a perfect square? Let's take b over 2 square, which is 3 square, which is 9. But our c here is minus 2, not 9. So this is obviously not a perfect square. So we are going to complete the square to force it to become a perfect square. So how so? Again, x squared plus 6x. I'll write these first two terms out. And then I plus b over 2 square. So 6 over 2 square. But if I add this, I must also subtract it. And then I just write the minus 2. So now, right now, the second line is equal to the first line. Again, x squared plus 6x plus, use a calculator, you should get 9. And then minus 9, and then minus 2. Now, if you use a calculator to factorize this quadratic expression, you should get x minus 3, no, plus 3, sorry, plus 3 square. And then minus 9 minus 2 is simply minus 11. And there you go. I've completed the square. Okay, so just one point to note is that sometimes teachers teach shortcut. They teach you a shortcut and students just memorize the shortcut. Okay, they don't even understand what they're doing. So I prefer to teach it this way. so that students really understand what they're doing. So perhaps they're going to take 1 or 2 steps more than if they were using the shortcut. But at least if you understand, you will fully understand what you're doing, okay? You won't make careless mistakes. So anyway, let's move on to the next question. Okay, example 3. All right, now this question is going to be slightly different. You will see why. So x squared plus 11x minus 15, x squared plus 11x plus b over 2. I get a fraction minus b over 2 square, and then just leave the minus 15 there. So I plus something, I plus this 11 over 2 square, and then I must subtract it, right? Same thing, right? Now, I get x squared plus 11x. Okay, I'll need a calculator for this. 11 over 2 square. 121 over 4. Minus 121 over 4 minus 15. Again, I'm going to use my calculator to factorize this. If you don't know how to do so, please refer back to my earlier video. So 111, 121 over 4 minus 11 over 2. So I must switch the sign. I get plus 11 over 2 square. And then this one, I just add these two together. Minus 121 over 4 minus 15. Get minus 181 over 4. All right. So first 3 examples are in elementary mathematics. They are quite easy. Okay. You notice beside my x squared, there is no coefficient. Okay. Now, why am I saying this? Because let's take a look at the next example. Now, let's take a look at this. You can see now, 5x squared minus 12x plus 3. There is a coefficient for x squared. Now, you don't see these kind of questions in elementary maths, but you will see this in higher level, like additional mathematics. Okay, so first thing I need to let you know is you cannot complete a square if there is a coefficient of x squared. I repeat again, you cannot complete a square if there's a coefficient of x squared, unless you're going to factorize the 5 out. So what do I mean? I need to do one more step. I need to factorize 5 out, and I get x squared minus 12 over 5x plus 3 over 5. So now that I have factorized this out, I'm going to continue writing this 5, but after that, I'm going to ignore it, and I'm going to continue to complete the square as per how I did it in elementary math. So x squared minus 12 over 5x plus, now b is actually minus 12 over 5, right? So I plus minus 12 over 10 square minus 12 over 10 square plus 3 over 5. Now, students will be asking, why is it this becomes 12 over 10? Because it's b over 2 square, right? So minus 12 over 5 over 2. And then students will get confused. How do we do this? It's actually minus 12 over 5 divided by 2, which is minus 12 over 5 times half. So isn't it minus 12 over 10? All right, so just remember next time, if you have a fraction and you're going to need to divide it by 2, just times 2 to the denominator. That's why I get my 5 becomes 10. Okay, simple to understand. Now, 5, continue up, x squared minus 12 over 5x. Let's use a calculator. 12 over 10 squared. And I get 36 over 25. Plus 36 over 25 minus 36 over 25 over 5. And then I close the bracket. Now again, I'm going to key this whole thing into the calculator. So I write my 5 first. 1 minus 12 over 5, 36 over 25. And I get 6 over 5. So I change the sign, x minus 6 over 5 square. And then this minus 36 over 25 plus 3 over 5. Minus 36 over 25 plus 3 over 5. So I get negative 21 over 25. But this is not over yet. Now, I factorized the 5 out just now, right? I have to expand it back. So what I'm saying is this 5 needs to times to this, and it needs to times to this as well. So there's nothing much to do for the first part. When you expand that, this just remains like that. You can't expand the 5 in. But 5 times negative 21 over 25, well, if you use a calculator, you will get minus 21 over 5. And there we go, we have completed a square. So in additional mathematics, I would say that maybe 2 more steps. What are the 2 steps? This, you need to factorize out the 5 first. Okay, then everything remains the same. You just do as per EMATH, complete the square, and you get this. But right now, the additional step is here again. Why? Because you need to expand. So 5 times this is just this, and then 5 times negative 21 over 25, and you'll get your negative 21 over 5. So completing the square, again, just means I'm forcing this quadratic expression into a perfect square. All right? Just remember, when you encounter questions with a coefficient for x squared, you must factorize it out because I cannot complete the square if there is a coefficient. I need to make sure the coefficient is 1. So make sure you factorize it out. Even if the coefficient is negative, you have to factorize out the negative sign. All right? So key points to note, in a quadratic expression, x squared plus bx plus c, notice I didn't put an a. I didn't put an a at the coefficient of x squared because in elementary math, there is no coefficient for x squared, okay? So anyway, in this expression, if b over 2 bracket square is equals to c, then it is a perfect square. Okay, to be able to complete the square, the coefficient of x squared must be 1. If it is not 1, you need to factorize the quadratic expression with the coefficient of x squared first. Okay, this is very important. All right? So I hope you learned something from today's lesson. Thank you very much.